So, good morning, one and all.
Good morning, sir.
Good morning, sir.
Good morning, sir.
So, again, the strength of analytical at the initial stage, it was very good. Almost all students were present, but unfortunately, in the last stage, probably we can say that because as the COVID-19 pandemic, the graph, I think lambda max is determined and that curve is going uh, in a downward direction. Hope so in the next month or after Diwali, we will see in the physical mode. But before that, we should be attend all lectures and whatever the activities are going on in online mode. Uh, that is also very important because in this month there will be a your IC exam should be there, and also I have told to all faculty that they have those who have completed topic should take the test, so that is very essential. And also then some changes has been going on. Some new CHB faculties are now available. So at the initial stage the scenario was different, and again the new CSBs will become from today, so there is also some reshuffling should be takes place. So be aware that we will take which topic and what is going on. That will be changed today probably, and then. But I think most of the syllabus is covered up till now, no? Almost 60-70% or more than
Yes,
that.
sir. So 70% till झाला.
Almost.
Yes, sir.
So most of the syllabus is now covered, and at the last stage, some faculties college has given permission because at the same time FYSYTY all divisions and that things are going on simultaneously, so the overlapping is takes place. So to avoid that one, some faculties are allowed. So in that case we will see. As today I will take this lecture, I don't know what about this topic, but as we have already covered the first topic in detail, and second also it is actually very less. I have told in the previous lecture that this topic is very short. Must it must include the HPLC and some part of GC, and then they move towards the crystal field, that is fluid chromatography. So just we'll start with our regular. I think no one will be coming after this. I think Raj, 13 are there. So what's about remaining five?
Sorry, sir, I don't know.
So you are here, na?
Now option atangi.
So charge is handover.
Yes, sir.
Okay, that doesn't matter. But you must know now how many students are there and who are not coming. So only she will not take responsibility. Everyone just check who is absent. Everyone knows. So just send the name of that. What's the problem of that we have to understand.
Yes.
Definitely, in this situation, they are having some problem. But we must know who are absent and because of which reason they are absent that we required. So on group, you should mention the name of that students, and also they will either call or write down whatever the reason is there. So some are having health issues nowadays, some having internet problem, whatever they having problem, we must that write down on WhatsApp group. So today you should write down the things. So you may discuss with Afsana and check who are absent and what is the reason behind it. Okay. So we'll start with our um, regular lecture. So I think you have already completed the assignment, or that is still going on. Everyone should submit it, or some are still that didn't come submit the assignment. Okay. So here, uh, on last lecture, we have already explained in detail the uh, chromatography, different types. In the supercritical fluid chromatography, just we can take the recap of previous lecture. In that we have seen the introductory part in detail, then application of chromatography, why it should be essential, and at which places it should be apply. Then we have seen different terms used in the chromatography, that is mobile phase, stationary phase, elute, eluent, solvent system, and that is the essential part we have already covered. So in the previous two lectures, we have focused on the classification of chromatography on the basis of adsorption partition. Just mostly they can classify, and also we have seen the different types of chromatography with their diagram, and whatever the mobile phase, stationary phase they have used, and the working most of them that you have already learned. That is thin layer chromatography, paper chromatography, ion exchange chromatography, then size exclusive chromatography, affinity. I think only size exclusive and affinity that you didn't actually handle. We have also gas chromatography, HPLC is also in our CFC. So that two instruments are already there. So that is nothing but in the different types of chromatography, whatever we have explained on the last lecture. And along with that, we have also explained supercritical fluid chromatography on the last slide. So that are the different types of supercritical chromatography and other types. So just we have seen, this is the last slide that we have observed. So just we can see the introductory part of supercritical fluid chromatography. It was first proposed by scientist J. Lawlock in 1958, and that technique was first used in analysis by Kelsper in 1962. So generally it is useful for the analysis and purification of low moderated molecule weight thermally labile molecules. And in this case, supercritical for chromatography, it is either liquid or gas which is used in a state of above critical temperature and pressure, where gas or liquid cannot be, or that can be exist as a coexist. And such kind of level in which there is a, so we can call it as supercritical, it having gases and liquid in coexisted, it having a viscosity very close to the gas and density is very close to liquid. And at this supercritical level, they having the very high diffusivity or diffusivity. So that is nothing but having very high diffusion, and because of all these three properties plays a very important role, and they having advantages over our normal HPLC and gas liquid chromatography. So it is a combination of these two, or advanced part of GLC and HPLC. Okay, so if you see the principle of this supercritical fluid chromatography, so it is a similar to the high performance liquid chromatography and GLC. However, supercritical fluid chromatography, it is typically utilize carbon dioxide as a mobile phase. Therefore, the entire chromatographic flow path must be pressurized, because here we can use a supercritical solvent as a CO2, and to maintain that condition we should require pressure. And because the supercritical phase represent a state in which liquid or gas and gas both properties are there, so that is a coverage or cover of both the properties, and that's why this is called it as convergence chromatography. So mostly such kind of question is asked in the MCQ. Supercritical chromatography is called it as convergent, or even in bits, generally such kind of questions are asked. So that's why the principle of this supercritical fluid chromatography is very important. So why it is called as convergent chromatography? Because it can represent the supercritical situation in which both liquid as well as gas properties are cover or converge, and that's why it is called as convergence chromatography. So did you understand the principle of this?
Yes, sir.
Yes, sir.
So it is very simple. Actually, on last lecture I also told some experimental part of HPLC in detail. So that is also very helpful to you. And no doubt here First of all, today we didn't see the instrumentation immediately because some part is also there. That is a new part for you. Now you can see the supercritical fluid chromatography advantages. First, the properties of supercritical fluid are between the gaseous and liquid state, and hence it has advantages of both HPLC and GLC. It having a low viscosity of mobile phase, which can permit to flow the rate of gas due to the high diffusion density of fluid and band wardening, which is greater than liquid but less than gas. So it having a properties in between the liquid and gas, and it is a situation in which they plays a very better role when individual gas and individual liquid can gives the analysis, and that's why supercritical fluid chromatography having a certain advantages. They offer faster separation with low zone of spreading that generally observed in GLC, that is gas liquid chromatography. If you observe that the fluid offer a better plate height, that is 0.013 than liquid. Okay, so that is 0.130 mm actually than liquid 0.039. So here in GLC, the mobile phase facilitate zone movement, while supercritical fluid chromatography, the mobile phase not only transport solvent but also interact and thereby influence the selectivity factor. So that is the important part in the supercritical fluid chromatography. So it can interact not only with solvent but uh, not only transport but it also interact. So or not more generally we know that the mobile phase is for movement or just it can carry the mm, molecules along with mobile phase. But in supercritical fluid chromatography, there is no need of particular solvent is there. So that gas is used as a solvent also, and that's why in HPLC and GLC we require separate gases. But here there is no need of gases there, and it can be interact, and therefore it plays a very important role. So the mobile, that is the molecule, is generally dissolved in this fluid. So this process is similar to volatilization of molecule in the GLC at low temperature, and the partial pressure which is higher for larger molecule, and hence higher molecular weights compound can be easily eluted. So generally, when we can see the HPLC and GLC, the high molecular weight compounds are very difficult to separation. But in this case, because of the solubility or easily dissolve the compound in the supercritical fluid, this process, which is similar to the uh, evaporation or simply called as volatilization of sample molecule in the GLC, and that's why it gives a advantage over GLC and HPLC. So thermally unstable species or large biological molecules can also be eluted even at low temperature. Generally, the unstable compounds or unstable species as well as some biological molecules, they are unstable at room temperature also, and that's why at this critical pressure and temperature situation, that molecules are also get separated by using supercritical fluid chromatography technique. Otherwise in GLC and HPLC they are very difficult to separate. So such kind of drawbacks which are observed because of use of HPLC and GLC, here they can be overcome, and that's why supercritical fluid chromatography having a certain advantages. Then solvent power is a function of chemical composition and density of the fluid with respect to the composition of fluid. Here we can use CO2 as well as water. Thus GLC operates for the molecular weight up to the 10 to 3 Dalton, while this CFC, sorry, SFC, that works 10 to 6 Dalton with a quite large number as compared to the GLC and HPLC. So here we use only one, either that CO2 or water we can use as a supercritical fluid which act as a solvent, and also uh, it plays a very important role because of its composition and density. So they easily get separated. So whatever the drawbacks we have observed in GLC and HPLC, that can be easily overcome by using the supercritical fluid. So this supercritical fluid chromatography, general question is asked for short, Answer: give the advantages of supercritical chromatography over GLC and HPLC, or compare the comparison of SFC with HPLC and GLC. Such kind of two question is always asked for short question. So you should write down these 6 points for that. Along with that, 1 2 point you have to highlight. Uh, that is nothing but so one of the advantage of the supercritical fluid having lower densities and viscosities than liquid, and this results in a larger diffusion coefficient. So if you observe over here, this results that is better efficiency and high optimization of linear velocities are observed, which is greater in SFC rather than HPLC. So here, if you observe, this is the curve of average linear velocity that can be observed over here. That is the reduction in elution time. Just we can observe as compared to the reduction in the peak width. We can observe there is sudden peak height is increases, but in this case we can observe this curve is very slowly and if you observe its height is also very less as compared to this one. So that's why it is a very important part that we can having the advantages of supercritical fluid. Also, whatever the illusion is there, we can observe the separation, and the retention time is also very less. We can observe in the supercritical fluid chromatography. Here we can observe the supercritical fluids having higher densities than gas. So when we can use as a mobile phase, which has a greater chance of interacting with solute than in gas chromatography. So in gas chromatography, we have used the carrier gas like helium, hydrogen, nitrogen. Here there is no need because that plays both role, CO2 as a supercritical fluid, and that's why interaction is takes place very effectively, and this makes the mobile phase important in determining the retention of the solute on the system, and that gives flexibility in the optimization separation. And if you observe here, they can be easily get separated. A sharp peak we can observe, and different column, that is the different stationary phases as we can used in the gas chromatography, and by changing the mobile phase in the liquid chromatography. So such kind of different column should not be required over here. So by using only one phase, we can carry out such kind of separation in a very simple manner, and here we can get retention time. So peaks can be observed at very less time is required. If you observe here, it required, suppose second peak is observed at 6 minutes. In this case, we can observe the second peak is just 1.3 or 2, and first peak is observed which is less than 1. Here we can observe it is observed at mm, after 2 minutes. So that time is less in the supercritical fluid chromatography. So these are the advantages. Generally question is asked on this, and this is a very very important part that we have to um, observe in the actually even though we can observe this part at the later part or last part of the topic, but in the syllabus this part is given before. So I have taken this part as a initial as far the syllabus is concerned. So I think these are the very important advantages of supercritical fluid chromatography over HPLC and uh, gas liquid chromatography. So question may ask directly advantages or comparison. So whatever the question is asked, that is you have to write down. Also the application, whatever the instrument you will see, definitely you should remember all applications, because such kind of question is asked in that also. And that's why these two questions are very important long question. Also some bits or MCQs are finishing, that we will also immediately give the MCQs which are based on the supercritical fluid chromatography. Now, once we cover these advantages, now we can see the other properties of supercritical fluid, how they can be mm, used. So first of all, we can see some basic terminologies that are used in the supercritical fluids. Critical temperature is the constant temperature that can observe. Critical pressure, that is the constant pressure. while the supercritical fluid temperature uh, is nothing but that every substance there is a temperature, actually it is called as critical temperature, above which it can no longer exist as a liquid no matter how much pressure is there. So it is a critical temperature, and for every substance there is a pressure above which it uh, can no longer exist in liquid state, even though how much temperature is raised. That is a pressure. So that is the critical points for both solid and liquid. And triple point is nothing but it is the point in which the state of matter was changed at constant temperature and pressure. So that is the solid is converted to the liquid, liquid is converted to the gases. That is the triple point. So melting point line and boiling point line that we have observed in the first phase diagram of your substance, that is critical pressure, temperature versus pressure. When we can see this is the sublimation is takes place started. This is solid is converted to the liquid, and this is a gaseous state. Solid is converted to the liquid. So this is the boiling point. So and here this is the boiling point, and this is the triple point when there is junction of solid, liquid as well as gas. This is a triple point line. So this is a critical point where the liquid mm, and gases are uh, having a conversion into the supercritical fluid region. So this is the supercritical fluid region. If you observe solid, then we know that they are compact, three dimensional they can observe, and when they converted to the liquid, then they can be move. There is a movement, so they can be no doubt they are in their periphery, but they can be a little bit structure is destructed, and in the vapor stage they can be having a very large movement is takes place. This kind of scenario we have observed in the solid, liquid and gas, but in supercritical fluid it is not exactly solid, not exactly liquid or gas, but it is a critical point through which it can be, even though such a fluid is there, so they are not much far away from each other, which are observed in the gas, and they are not much close as compared to the liquid, but they are having a supercritical situation that called as a fluid one. Okay, so these are some basic terminologies that are commonly used in the supercritical fluids, that is critical temperature, critical pressure, then no, that is the normal temperature and pressure, that is a constant through which solid is converted to the liquid or liquid is converted to the vapor, or sublimation when the solid is directly converted to the vapor state. And when these 3 points are come together, and that point is called as triple point. So that is observed over here, and this is a critical point. So this diagram is represent the phase diagram of pure substance, any pure substance. Okay, so that easily converted to the solid is converted to the liquid, liquid is converted to the vapor, and here we can get a supercritical situation in which they gives a higher region with respect to the solid, liquid and gas. So the supercritical fluid, it is an substance at temperature and pressure above the critical points. It can diffuse through the solid like gas and dissolve material like liquid. Additionally, it is close to the critical point. A small change in pressure or temperature, which results in a large change in the density, and that can use many properties to be available or tuned for this supercritical fluid. So it is a fluid. So it is suitable as a substituent for organic solvent in a range of industrial as well as laboratory processes. Mostly it is useful in the industries and highly in the research that supercritical fluid is used. So in a supercritical region, generally the substance is neither gas or neither liquid, but it is fluid. Fluid is nothing but it is in between liquid and gas. So that having both properties, liquid as well as solid, and that's why it is called as supercritical. And there is no sharp boundaries between this gas and liquid in a supercritical. Initially we observed liquid is connected to the gas, solid is converted to liquid, liquid is converted to the vapor stage. But here there is no such kind of boundaries observed, so that we cannot observe any kind of line or junction is there. So it is a combine of both gas as well as liquid, and that's why it having no any kind of sharp boundaries is observed for gas and liquid. So they are mixed in a such a way that they can be formed in a supercritical position. So the properties of supercritical fluids can be very different from normal liquid phase, normal gas phase. So when we can compare the properties for normal gas as well as liquid, they're having different with respect to the supercritical fluid. So such are some introductory part of supercritical fluid. Now we can see how they can be observed in a solvent system. Okay, so we'll see the properties of supercritical fluids. So again here the properties are asked, or what is meant by supercritical fluid, give the properties and application of supercritical fluid or advantages of supercritical fluid. Such kind of question is asked in the exam, and that's why this part is very important. So as we see the properties of supercritical fluid, it having a high densities, so that they having a remarkable ability to dissolve large non-volatile molecules. So supercritical CO2 can dissolve an alkane that having more than 30 carbon atoms. So very large molecules can be dissolved in the supercritical. Otherwise, in normally when such kind of molecules we will take, they are not dissolved in liquid, and that's why supercritical situation in which it is having both properties of liquid as well as gas, and that's why they having a ability to dissolve the large non-volatile molecules very easily, even though they are having higher density. So this is the first property that we have to observe. Then it dissolve the all kind of analytes or samples in the supercritical, and after completion of analysis they can be easily recovered by simple allowing the solution to equilibrate with atmospheric at low temperature. So very useful such kind of technique, that thermal unstable analytes can be easily removed. Otherwise, generally we observe when there are unstable analytes are there, then the solvent removal is a very difficult task, because during this decomposition is takes place. So to avoid that one, such kind of supercritical technique is very useful. So analyte in supercritical CO2 can be recovered by reducing the pressure and allowing the CO2 to vaporize. So such kind of both having temperature and pressure, so we have to adjust in a such a way that the CO2 can be evaporate and pressure is reduced, and easily we can recover the sample. So this is a very important property of supercritical fluid. Even when we can see the cost, it is also very effective. It is inexpensive, innocuous or non-toxic, and that's why this can be applied more in industries. We remember, otherwise what will happen, when we can use normal solvent, then there is a problem regarding its handling, and when we can preserve for a long time, then there causes some accident also. So to avoid that one, supercritical CO2 is more useful because of its non-toxicity as well as inexpensiveness. Now even it is eco-friendly. So how you can call it is eco-friendly, or generally it is cost effective also, because there is no need of special organic solvent is required. So we have seen in the different technique like HPLC, GC, we used liquid solvents, along with we can use gas for carrier of the sample. We use a different kind of combination of polar as well as non-polar solvent, but here there is no need of such kind of solvents are required in the supercritical fluid chromatography, because it is a fluid, it is plays both properties of liquid as well as gas, and that's why it called it as eco-friendly. So supercritical fluid is eco-friendly because there is no need for special organic solvent which in which the sample can be dissolved. Okay, and at uh, supercritical condition, they having high diffusion coefficient and low viscosities, related to the liquid, and faster and higher resolution for the separation is takes place because of the high diffusion rate of coefficient and low viscosity. And that's why when you can compare the liquid properties and gases properties, here there is a combination of liquid as well as gas, and that's why it having a diffusion coefficient very high, so that can be gives a higher resolution for the separation. I think these are the properties. So did you understand these properties?
Yes, sir.
Yes, sir.
Okay. So these are very important property as compared to the normal liquid and normal gaseous, and also we cannot use organic solvent because here we use a supercritical fluid. And now when we can see the supercritical that exists at temperature and pressure above its critical temperature and pressure, and hence density, viscosity, and other observed in its observed in its gaseous as well as liquid state. But when they are observed in the supercritical, they are having a different range. So generally we can compare the density, diffusion coefficient, as well as the viscosity of the sample or substances. Both are in gaseous liquid individually, and that having a very different change in the supercritical fluid. Now when you can see the it having mostly lower viscosity related to the liquid solvent, and greater diffusibility means it having a longer column length that can be used very commonly, and because of the increase in the length of column, it increase the diffusibility, and higher diffusion coefficient means higher is the analysis, and it is takes place very speedily. So that is nothing but the higher diffusion coefficient is very important factor in the resolution as well as in the analysis of the sample, because of the in very less time they can be analyzed at higher quality separation, and that can be take place because of the higher diffusion coefficient point. So here as it having low density or low viscosity as compared to the liquid, so whatever the properties are there, that is density, liquid, for gas as well as supercritical, that can gives the different values that we are observing in the table. Now generally which kind of properties are required for the solvent which act as a supercritical fluid? So always we prefer the good soluble of the samples in that supercritical fluid, and it having a very good penetrating properties. So such kind of solvent is used as a supercritical solvent, that is fluid solvent, and also it is inert to the product. Otherwise what will happen during the interaction, uh, that is useful for fragmentation. So when we can carry out inertness, that if fragmentation carried out and they is having any kind of reaction with the that fragments, then it is very difficult, and that's why there is a very important property when we can choose the solvent for supercritical fluid. So here easy separation from the product is takes place. That is also very important part, because once you can carry out this analysis, the removal of the solvent is also very important part. Then one more important criteria for the choice of good solvent of supercritical is the cheap. So it should be easily available, and it cost is also very less. Now, so when we can see the low cost, or they can be having very cheap. So on the basis of economic reason, that are also very easily applied. Now we can see which are the solvents that are commonly used. So supercritical fluid solvents, generally we use carbon dioxide and water as the most commonly used supercritical fluids, being used for uh, decaffeination as well as power generation, they can be used as a supercritical fluid. Many pressurized gas are actually supercritical fluids. For example, nitrogen is also act as a supercritical. But when you can compare the properties of different molecules that we'll see on the next table, then we can say that CO2 is CO2 and water that are commonly used. And that's why in many industry, because they are easily available, and it's cost or cheaply they can be used, and even though they can be separated very easily, and that's why they're having a very good quality for the supercritical fluid as a solvent. So nitrogen or compressed air in a gas cylinder above this pressure is actually supercritical. So for nitrogen, we also used as a critical fluid. They are more often known as permanent gas. At room temperature, they are well above the critical temperature, and therefore they behave as a gas. Similar to CO2 at 400 Kelvin, we can observe that nitrogen is also uh, in the gaseous state, but however they cannot be liquefied by pressure unless cooled below their critical temperature. So generally nitrogen, that is liquid nitrogen, is also available. We can feel that liquid nitrogen in the inner atmosphere. Also we can use in the NMR, and even some instrumentation. There is a requirement of nitrogen in the liquid form is there, and that's why the nitrogen liquid and nitrogen gases having different properties. But when we can use supercritical fluid, uh, CO2 is best choice as compared to the nitrogen. No doubt it can be used, but commonly we can use CO2 and water. So these are some commonly used fluids as well as their critical temperature and pressure. So CO2, ethane, uh, propane, propylene, trifluoromethane. Also we can use chlorotrifluoromethane. They are having a certain critical temperature and critical pressure that have been mentioned. CO2 30.41, 73.8. Now we will see the two supercritical fluids, just properties and their phase diagram. First we will see the CO2. In the CO2, it is a non-flammable. Everyone know that it is non-toxic. It having low critical temperature and moderate critical pressure. Generally, mm, it is miscible with variety of organic solvents and is readily recovered after processing. So the recovery of the gases takes place. So fluid is easily takes place. Also, it diffuses faster than the conventional liquid phase or liquid solvent system. Generally, we can use. So this is the phase diagram in which we can observe. This is the gas. This is above this. There is solid. Below this there is liquid, and here is a gaseous state. And we can observe this is a critical pressure and temperature at which we can observe these two phases are in this point, that is critical point, and above this critical point whatever the liquid and solid gases are observed, they are in a supercritical fluid. And this is the scenario of CO2. Just you have to know the uh, mm, some properties related to the CO2 as well as uh, water. So it is very commonly used solvent for supercritical fluid CO2 as compared to water also. Now, this is the critical temperature of water. So again, the critical temperature and critical pressure are moderated and that having a very high polarity. Then the character, as the water is highly polar one, the character of the water at supercritical condition changes from one that supports by ionic species at ambient temperature or conditions. So that dissolve paraffin, aromatic gases, and salt. And that's why, in this case, due to the unique properties, research has been carried out on supercritical water for reaction and separation process to treat toxic waste from water. So if you can use this property of water, that is supercritical, then it is very easy to remove the water waste. So it is very important in the nowadays we are facing the in environment, that is waste management for solid as well as liquid. So mostly in the water, if you able to remove the toxic material from the water, so by using this supercritical uh, water, they can be easily removed. And that's why water having a very important role in the supercritical. So again, that having a same diagram, that is in the solid state, water is in the form of ice, and in the liquid state it is in the water, while in the gas it is in the form of steam. So all these three they have been mentioned. This is the triple point, and this is critical point. And above this critical point, there is a supercritical fluid, which is observed, which containing the both properties of solid, liquid as well as gases of the water is available in the supercritical, and they can be easily uh, operated and removed from the organic components. So these are the water and CO2 as a supercritical fluids. What are the advantages of supercritical fluids now? So we have observed, and that's why the question is asked on this: what is meant by supercritical fluid? Give the properties, and what are the advantages? So again, a long question is asked here on this part. Now, the advantage of supercritical fluid over carrier gas and liquid mobile phases are in its solubility properties, physical properties, and detector compatibility. So because of the only one um, supercritical fluid is used instead of other solvent, uh, and it having a very great uh, property of solubility, so they can overcome the carrier gas properties as well as the liquid mobile phase, and they used separately in liquid and HPLC, but here in supercritical we can use directly supercritical solvent like CO2 and water. So it act as a mm, not only solvent, but it is used as a supercritical fluid, and that's why it having certain advantages. Now when we can see the solvating properties of supercritical fluid, it is very similar to the many conventional organic solvent and much higher than gas. So generally, the organic compounds are easily soluble in the supercritical fluid condition, and also it is having a much higher properties than gases. Now, the diffusion coefficient and viscosity of supercritical fluid are about 5 to 50 times higher than that of liquid. The high density of supercritical fluid able to dissolve many non-volatile molecules very easily. So these are also very important advantages. Like CO2 dissolve N alkane of having a N number is almost 5 to 22. So such kind of huge alkane molecules can be dissolved in the supercritical CO2. Otherwise, it is very difficult. Even though polycyclic aromatic hydrocarbons that can be easily dissolved in a supercritical fluids. So analytes can be easily recovered by allowing the solution to equilibrium at lower temperature, so they can be easily recovered from the supercritical. Then divisibility of the solid is very high, that we already see the previous slide, that is the advantages of supercritical fluid. Then viscosity is low, so very useful to for compounds which having no functional group, so they can be detected by using method in HPLC. So on the basis of requirement, we have to apply for the different compounds because of the low viscosity of the supercritical fluids. And even though the molecules or compounds they do not have any functional group, so they can be detected by using this uh, supercritical fluid chromatography. And generally, when we can observe this, not observed in the HPLC. So HPLC is failed to use such kind of properties. So these are the advantages of supercritical fluid. Mostly question is asked on the advantages. So actually the instrumentation part is there, that is the instrumentation of supercritical fluid chromatography. Generally it involves mobile phase, stationary phase. We have to explain on that. Then pump is there, injection port is there, oven because it requires under pressure, so oven is there, column is there, and detector is there. So we have already seen such kind of points in the previous topic. Now here we have to explain on the basis of supercritical fluid chromatography, so it having a different instrumentation part. So as this is the instrumentation part of this topic, and then we can see the application. So on next 1 2 lecture we will cover this instrumentation part of supercritical fluid chromatography, and then we'll see the application. So this note, this topic is very less, having even though they given a 15 lecture, I didn't know how they can be calculated. But whatever their part is there, we have to cover. So as it is autonomous, so if we see different syllabus of different universities, even I have also observed. So this is not having a weightage of full chapter. It is in combination with HPLC always. So because in HPLC they will explain detail, like we have explained in mass spectrometry. So such kind of explanation is there in the HPLC, and after that in advancement we can use the supercritical fluid chromatography. So this is a very I think you are lucky that it is a very easy chapter is there for you. And at third semester, even they having a 5 different papers, so such kind of topics plays very important role. So the questions are easily asked, and whatever there is. So I think this is a very important part, but today uh, we have very less time to explain what is the use of supercritical. Before we can see the instrumentation part, one more important part that we will see on next lecture, and then we can start the instrumentation on probably next lecture. Okay, so I think we'll stop over here, and then we can see the instrumentation. So as far as this topic is concerned, and even some other part, if there is any kind of difficulties, please discuss, as we have 5 minutes still available. And mostly the different activities in our college is going on, like research paper and poster. Those who are included in that, we remember that poster and paper, that activity is also going on. Some PDP3 people going on, skill is there, and in that you have to involve. So because why mostly please open your video, so I will just discuss something. So everyone be remember that whatever part we have covered, if there is requirement of any additional information, then on next lecture I will see explain in detail. That is the one thing. And the second thing, whether this research part is concerned, I think you are in the third semester, and it is very difficult to work in this semester. So probably in the last semester you should work, and that is converted to the your paper. So it is better way that you should focus on the your review. So if there is any kind of difficulties, please ask. Okay, Apsana, if you have any doubt regarding this topic.
No, sir, no doubt. Clear.
Okay, Anupama.
No, sir.
Okay. Samarveer, what's about you?
Yes, sir.
Okay, so so do you completed your assignments all up till now?
No, sir. Due to sir health problem, I'm sir on bed rest, sir.
So you have any so regarding COVID-19 or any other?
No, sir. In a viral infection, sir. No other
Okay,
infection.
okay. So just take care because the situation now is going to normal. So whatever the number is observed in the last 2 days, it is really hopeful that we will cover really early. As far as I think in the October or November we will probably meet. Hope so. And before that, you should cover your review article. Be ready, right?
Okay, sir.
So what will
Okay.
happen once if there is any kind of work is there now, so there is two papers you can carry out simultaneously, one on the basis of review, and whatever you do the review, that immediately converted the work, because you know that what is part is covered and what is left. So you just focus on that and you can convert to the new thing in your paper. Okay, that is the benefit of actually your article. Apsana, you want some to say something?
हां सर. सर रिव्ह्यू कधीपर्यंत द्यायचे आहे मला? सबमिशन कधीपर्यंत आहे?
रिव्ह्यूचं सबमिशन असं हे नाही केलेलं, पण हे तुम्ही तयार ठेवा. तुमच्या जे काही शंका असतील त्या त्या ठिकाणी सरांशी चर्चा करून घ्या. तुमचे जे मेंटर असतील त्यांच्याशी, ज्यांना मेंटर नाही आहेत त्यांच्या संदर्भामध्ये त्या त्या ठिकाणी बहुतेक ह्या आठवड्यामध्ये आता MSc सेकंडची एक्झाम आहे, ही जर उरकली की थोडंसं मी तो फायनल करून घेतो, आणि जर वेळ मिळाला तर 1-2 दिवसामध्ये मला वाटतं सॉल्व्ह करून घेता येईल. परंतु काहींना ज्यांना माहिती आहेत त्यांनी रिव्ह्यू हे करून घ्यायला हरकत नाही. आता ऑलरेडी तुझ्याकडे
ओके.
तर माळी मॅडम आहेतच, त्यामुळे मला वाटत नाही काही तुला अडचण आहे त्या ठिकाणी.
नाही, नाही, नाही सर.
हा हा. अजून कोणाला काही शंका?
सर थर्ड सेमिस्टर कॉलेज समजा नोव्हेंबरमध्ये सुरू झालं तर थर्ड सेमिस्टर कॉलेजमध्येच होणार आहे का ऑनलाईन होणार आहे?
नाही नाही नाही, आता का होईल सांगतो. म्हणजे त्याबद्दलच्या गाईडलाईन अजून कुठे क्लिअर आलेल्या नाहीत. एक ऑटोनॉमस मध्ये आपण ऑनलाईन मोडमध्ये खूप लवकर सुरू केलेलं असल्यामुळं, म्हणजे तसं पाहायला गेलं तर जुलै, ऑगस्ट, सप्टेंबर, ऑक्टोबर गेली 4 महिने झाला आपण ऑनलाईन मोडमध्ये आहोत. आणि त्याच्यामध्ये 4 महिन्यामध्ये तसा रेग्युलरला सिलेबस संपतो. बरोबर आहे. तुम्हालाही माहिती की मागच्या सेमिस्टरचा निकाल आणि त्याचं सिलेबस, तर त्या मानाने मला वाटतंय तुम्ही खूप ऍडव्हान्स सिच्युएशन मध्ये आहात की आता ह्यामधलं एकच तुम्ही करा की तुम्हाला ऑनलाईन मोडमध्ये कोणता पाठ समजलेला नाही, हा तुम्ही थोडस प्रत्येकाने म्हणजे हे आत्मपरीक्षण करणं गरजेचं आहे, किंवा ह्यातला कोणता पाठ आपल्याला जास्त समजलेला नाही, काही कळलेलं नाहीये. आणि मग जेव्हा तुम्ही फिजिकल मोडमध्ये याल तेव्हा आपल्याला डेफिनेटली रिव्हिजन आपण घेणारच आहोत. म्हणजे असं काही नाही की शिकवलंय म्हणून झालंय आणि ते नाही. तर ऑनलाईन मोड त्यांनी घ्यायला झाल्यानंतर ऑफलाईन मोडला पण हे परत रिव्हिजन घेऊ, परंतु तुम्ही थोडंसं त्यामध्ये पाक्यातला कोणत्या पार्टवर आपल्याला जास्त फोकस करावा लागेल, आणि मग त्यानंतर त्याची एक्झाम जी आहे ती तुमची रेग्युलर प्रमाणेच होईल असं वाटतंय, आणि मग काय अडचणीची शक्यता वाटत नाही. पण मला वाटतं
आणि
बऱ्यापैकी तुम्हाला समज. हा, बोल बोल.
आणि
सर तरी
सर
सुरुवात
1 नोव्हेंबर
हा,
पासून तर नवीन वर्ष
एक
सुरू
लक्षात
होणार
घ्या.
होतं.
हा, म्हणून मी तुम्हाला म्हणलं की तुम्ही सगळ्यांनी तुमची व्हिडिओ ऑन करा, म्हणजे मला जरा समजेल आणि ती सिच्युएशन तुम्हाला सांगता येईल महत्वाची. कारण ह्या ठिकाणी एक होणार आहे की जरी 1 नोव्हेंबर सांगितलेलं असलं तरी माझं ओपिनियन वैयक्तिक मध्ये अर्थात ते काही हे नाही, तर 1 नोव्हेंबर असलं तरी सुद्धा ते थोडंसं पुढे जायची शक्यता मला तरी वाटते, एक 15 तारखेपर्यंत. आणि तिथून पुढे मात्र ते सुरू करतील, कारण मधल्या ह्याच्यामध्ये थोडीशी दिवाळी येते. आणि 1 नोव्हेंबरला जर ते सुरू करायचं म्हटलं तर त्याच्या अगोदर त्यांना काही गाईडलाईन द्यावे लागतील शेवटच्या वीकमध्ये, की जे काही कॉलेजेस आहेत त्या कॉलेजेस किंवा ज्या शाळा आहेत, म्हणजे अर्थात कॉलेज असं नाही, जे काही आहेत त्यांचे शाळा नाही, तर ते सगळं सॅनिटाईज करून घेणं वगैरे हा प्रकार करून सांगून 1 तारखेनंतर ते सुरू करतील आणि अंडरटेकिंग हे घेतील. जर आपल्याला तशी सिच्युएशन मिळाली तर तुम्ही आता तुमच्या बाबतीत होतंय काय की सगळे इथं राहणारे नाहीयेत. तुमच्यातले किती जण आहेत सातारामध्ये राहणारे, बरोबर आहे की नाही? तर मग ते तुमच्या ज्या काही रूम आहेत किंवा तुम्ही जिथं पूर्वी राहिला होतात, जे आता हॉस्टेल आहेत मुली, त्यांची काही अडचण यायची शक्य नाही, पण मुलांच्या बाबतीत थोडीशी शंका आहे. तर मग ते तिथं येऊन राहणं आणि ते करणं, ते सिच्युएशन जर क्लिअर झाली तर मला वाटतंय त्याला परत दिवाळीची मध्ये हे येते ते 5-6 दिवस जातील. म्हणजे सुट्टी आता पहिल्यासारखी जास्त मिळणार नाहीच आहे, पण ते 5-6 दिवस जातील, आणि त्याच्यानंतरची तारीख जी येते म्हणजे सांगता एक 15 तारखेनंतरची, तर तिथं मग रेग्युलर सुरू व्हायला काही हरकत नाही. परंतु तुम्ही सगळ्या ह्याने तयार राहा. म्हणजे आता जी काही टीवायची सिच्युएशन झाली पोरांची, की इव्हन एमएससी सेकंडच्या मुलांची, की त्यांना काय वाटलं की असं काही होणार नाही आणि आपण आता रिलॅक्स राहावं, तर थोडंसं मग अडचणीचं होतं. आणि आता ऑलरेडी आपण एवढं शिकवलेलं आहे, तुमच्याकडे सगळं मटेरियल आलेलं आहे, तर त्याच्यामध्ये जर तुम्हाला काही शंका वाटत असेल तर तुम्ही ते लिहून काढा किंवा तुमच्या चर्चा करा. मला वाटतंय अनुपमा, यू हॅव एनी डाऊट रिगार्डिंग व्हॉट एव्हर द पार्ट कवर्ड इन द analytical chemistry?
No, sir, it's okay.
Okay, so be remember that everyone should that suppose those who are talent students, or they having very good marks, or they having very good ability to capture all the things in online mode, but it is not necessary that every student having that same capacity. And that's why I'm telling to one and all that you should remove that points from your whatever the topics you have covered, and you should discuss among others also. So once you have do such thing, then what will happen when we will come, then there is should be some interactive sessions we will carry out. Those having clear doubts, then we can interact with yourself, so we also understand, or we also judge that how you can understand the part and other is not understand, so that we can carry out interactive sessions. Okay, so that kind of part we will cover, and then immediately there should be a exam. But even college has decided to take the online mode exam, then you should prepare for that. So you do not just you have to attend the lecture and didn't do anything. So within last 4 months, I think you should uh, know each and everything, whatever the material is given, as well as whatever the assignments are given. And that's why I'm asking every time that you should be focused on your assignment. So that is very important part. So once you can write down a whole thing in your notebook, then it is very easy to understand the part. So I think we will stop over here, and on next lecture we will see the instrumentation part of this. So whatever we have seen, this is very important. So always question ask on this part. Okay, thank you.
Thank you, sir.
Good morning, all.
Good morning, sir.
Morning, sir. Good morning, sir.
सर्वांचं लेक्चर संपलं.
Oh,
हो, sir.
कॅमेरा स्टार्ट करा जरा. Start your camera. ओके, ते तसंच होईल कारण फक्त अर्धा तास घेईल. आणि तुमची 11 वाजता आज ही आहे ना COC ची परीक्षा.
Yes, sir.
oh, sir.
ती परीक्षा टाइमला होईल तुमची. धनवड सर आणि गायकवाड सर घेतील ते. ओके. So we have a 30 minutes. So we'll take 5 minutes for the recap and next 20 minutes for the next part. Okay. Let me share the screen. Okay. The screen is visible.
Yes, sir.
Yes, sir.
So in last lecture, we have seen about the NMR interface. Okay. So there are two types of interface. First is the direct coupling. Second is the indirect coupling. Under direct coupling, you have two types. One is the post column splitter, and second is the wall switching interface. Okay, so this is the first type, direct coupling. And indirect coupling, we use the storage loop where sample is being stored in this loop. That's why it is called storage loop. And it is indirect, means there is no connection between the HPLC and NMR. So sample first will collect in the storage, then it will be moved towards a move in NMR system. So that's why it is called indirect coupling. So this is the image or picture of the direct coupling. Here you can see that two parts are connected directly. Just there is a two walls between LC and NMR. So this is the upper part is about the LC. This is LC instrument. This is the NMR instrument, and these two walls are used for send the sample directly into the NMR. Whether you can send the sample into NMR, if you don't want to use that sample for the analysis, then you can take that samples to the waste as a waste from this side. These two walls are three-way. Three-way means here you can see that one is inlet and there is two outlet. That's why it is called three-way wall. So sample will come from one end and it will go either two end. One end is to NMR and second is to the waste. So that's why it is called three-way. This is the second wall which is connected in between LC and NMR. Sample will come from the LC and it will pass through this second wall along with the resolution of solvent. Like we use solvent in NMR, CDCl3 or D2O. So we can inject that solvent, NMR solvent, through say one number. So this is the three wall. So here sample along with the solvent will pass through the NMR and analysis will be done in this part. So this is the direct coupling. This image is for the indirect coupling. Here you can see that there are two blocks. One is the LC block and second is the NMR block. Okay, so this part is about the storage loop, indirect coupling or interface, we can say that. So always remember, storage means sample will be stored in different parts. Okay, after separation you will get the pure sample, and that pure sample will be stored in different parts. So which sample you want to analyze, you can analyze by using that store loop. So image of the storage loop is like this one. This is the first image you can see here, and this is the second image. So sample will be stored in this storage loop. Okay. Then instrument part of the NMR. As we know, there are different components used in the NMR. First one is the magnet, strong magnet field we use. Okay. Then RF channels to pass the radio frequency wave, and second is the sample probe. Sample probe is the center part of the NMR where there will be RF field, sample holder, RF oscillator, shift generator, and RF receiver. So all of these make the sample probe. हे सर्वांचा मिळून sample probe होतं. Okay. And then last part is the detector. Okay. So this is the image, general image or simply NMR. NMR ची इमेज आहे फक्त हे. ओके, कन्व्हेन्शनल NMR म्हणतो, ज्याच्यामध्ये हे सर्व पार्ट्स आहे आणि याच्यामध्ये आपण जर बघितलं तर दिस इज द सॅम्पल ट्यूब. ही सॅम्पल ट्यूब आहे आणि इट इज ऑलवेज वर्टिकल अँड रोटेट अलॉंग द एक्स ॲक्सिस. सो इट इज स्टे वर्टिकल आणि त्याच्याभोवती आपण हे कॉइल्स वाइंड करतो. These coils are for the radio frequency transmitter. Okay, this is the strong magnetic field. Okay, so this is strong magnetic field used to generate the very strong field around this sample. But always remember, when you using a strong field or strong magnet, you cannot change directly. जर तुम्हाला field त्याचं change करायचं असेल तर तुम्ही change करू शकत नाही, कारण it is very difficult to change the its magnitude. जर तुम्ही 500 ला ऍडजस्ट केलं असेल, इफ यू वॉन्ट टू कम 450 or 550, यू कॅनॉट डू इझिली, तुम्ही ते करू शकत नाही. सो व्हॉट दे डू, दे जस्ट पुट अनदर मॅग्नेटिक फील्ड. ओके, त्यासाठी काय करतो आपण, हे मॅग्नेटिक फील्ड आहे, इट इज कॉल्ड शिप कॉइल्स. देर आर टू शिप कॉइल्स अराउंड द सॅम्पल अलॉंग विथ द मॅग्नेटिक फील्ड. ह्याच्या साह्यानं आपण काय करू शकतो, आपल्याला जर मॅग्नेटिक फील्ड चेंज करत असेल बाय 50 मेगाहर्ट्ज और बाय 70 मेगाहर्ट्ज, we can change by using SIP coils. Okay, so this is the application of the SIP coils, and this is the recorder. Radio frequency will be recorded and analyzed, and it will give the NMR spectrum. So this is the conventional NMR spectroscopy. Okay. त्याच्यानंतर आपण वेगळे पार्ट्स बघितले होते, मॅग्नेटचं काय काम असतं ते बघितलं होतं, टाइप्स ऑफ मॅग्नेट बघितलं होतं. देर आर 3 टाइप्स ऑफ मॅग्नेट, परमनंट, इलेक्ट्रोमॅग्नेट अँड सुपर कंडक्टिंग मॅग्नेट्स. त्याच्यानंतर मॅग्नेटिक कॉइल्स बद्दल बघितलं. देन नाव ओके जस्ट मिनिट, हां रेडिओ फ्रिक्वेन्सी बद्दल आपण चर्चा केली होती. नाव आवर नेक्स्ट इम्पॉर्टंट पॉइंट इज द LC-NMR mode of operation. So this is very important point because in exam this is a very important question can be asked on this point. So how NMR LC-NMR works, कसं काम करतं, that is the mode of operation. Okay, so generally LC-NMR experiment can be performed mainly in 3 modes. नेहमी लक्षात ठेवा 3 पद्धतीने आपण this LC-NMR do. Wait a minute, just okay. So there are 3 ways we can use this LC-NMR instrument. Okay. Okay. The first one is the continuous flow LC-NMR system. So this is the continuous flow NMR system we can use. In this case, the relevant samples which LC madna येणार आहे in real time as flowing through the NMR detection point. जसं सॅम्पल येईल तसं ते आपल्याला पुढे फॉरवर्ड करायचं आहे. सो देर विल बी नो स्टॉप, कुठं आपल्याला थांबायचं नाही, काय करायचं नाही. जसा फ्लो येईल तसं ते सॅम्पल पुढे NMR मध्ये पास करायचं. सच सिस्टम इज कॉल्ड एज द कंटिन्युअस फ्लो ऑन फ्लो NMR mode of operations. Second is the stop flow. So this is the exact opposite to the first one. This is the stop flow, means here you can take the stop. तुम्हाला ते सॅम्पल थांबवून ठेवू शकता. ओके, तर काय करायला लागेल, जस्ट यू हॅव टू स्विच ऑफ द पंप. जो आपण पंप वापरतो LC मध्ये तो आपल्याला स्विच ऑफ करायचा. सो युअर सॅम्पल विल बी स्टॉप देअर. म्हणजे पहिलं सॅम्पल आपल्या समजा एका मिक्सर मध्ये 3 सॅम्पल असतील, 3 कंपोनंट असतील. पहिला कंपोनंट बाहेर आला बरोबर, तर आपल्याला तिथं थांबायचं आहे. सो यू कॅन जस्ट स्विच ऑफ द पंप. सो सेकंड सॅम्पल विल स्टे इन द LC and first sample will enter into the NMR. So this type of mode is called the stop flow. Okay. Under the stop flow, it is modified version is the time slice. Okay. ते आपण पुढे बघूया. टाइम स्लाइस मध्ये त्याचाच प्रकार आहे. ओके, and then next is the peak packing. म्हणजे याच्यामध्ये peaks of interested are packed in offline sample loops. म्हणजे आपल्याला जे इंटरेस्टेड सॅम्पल आहे किंवा जे इंटरेस्टेड कंपाऊंड आहे त्याला आपण सेपरेट करून त्याचा अनालिसिस करू शकतो. सो इट इज कॉल्ड पीक पॅकिंग. ओके, सो दीज आर द इमेज ऑफ द मोड ऑफ ऑपरेशन. हे तुम्हाला जर प्रश्न विचारला तर याची इमेज काढू शकता. आता याच्यामध्ये फक्त एक लक्षात ठेवायचं, याच्यामध्ये 3 इन्स्ट्रुमेंट वापरलेले आहेत, पण आपण फक्त LC-NMR बघतोय बरोबर. तर ही जो मास स्पेक्ट्रोस्कोपी आहे तर तुम्ही याच्यासोबत वापरू शकता. सो इट विल बिकम 3 instrument hypnotic technique. One is the mass, second LC and NMR. But just we are concentrating on the LC-NMR. So we are not discussing the mass. बरोबर, आपण मास डिस्कस करणार नाहीये, फक्त आपण LC and NMR डिस्कस करणार आहे. ओके, सो फॉरगेट दिस इमेज. मास स्पेक्ट्रोस्कोपीची इमेज विसरून जावा, आपलं काही गरज नाही. सो ओनली LC and NMR. So there are 3 types. This is the first one, this is second, and this is the third one. The first one is about online or continuous flow mode. So this is the online or continuous mode. Okay, so you can see that this is the first online or continuous flow mode. Second is the stop flow. म्हणजे आपण जे बघितलं stop flow mode. And third one is the loop or cartridge mode. So there are the three modes you can see and there will be a difference. आता याच्यामध्ये तुम्ही बघू शकता पहिल्यामध्ये एल सी आहे क्रोमॅटोग्राफिक सिस्टीम म्हणजे काय आपलं HPLC त्याचं डिटेक्टर आणि डिटेक्टर मधनं सॅम्पल आलं की डायरेक्टली ते पास होणार आहे कुठेही थांबणार नाही त्याला काही होणार नाही सो इट विल डायरेक्टली एंटर इन टू द NMR डिटेक्शन दॅट्स व्हाय इट इज कॉल्ड. सेकंड मध्ये काय आहे HPLC आहे डिटेक्टर आहे डिटेक्टर मधनं सॅम्पल पास आलं की याच्यामध्ये तुम्हाला एक इंटरफेस आहे बरोबर आहे जिथं तुम्ही सॅम्पल कलेक्ट करू शकता. Okay, sample collect other, so you can pass this sample either through waste or towards NMR system. So here you have a stop. जसं आपण एखादा प्रवास निघालो की आपण थोडं थांबतो मध्ये त्या प्रकारचं वर्किंग आहे. So sample will be stopped here and then it can pass into the NMR system. Now third one is the loop or storage mode. So this is the interface. Okay, this is the main interface. And this interface is called the loop or cartridge storage. Okay, and this is important. So in this case you can store many sample in a mixture. जे कंपाऊंड असतील एका मिक्सर मध्ये 5 कंपाऊंड असतील तरी तुम्ही काय करू शकता याच्यामध्ये स्टोअर करू शकता आणि तुम्हाला जे सॅम्पलचं फक्त अनालिसिस करायचं आहे समजा 5 सॅम्पल तुम्ही करायचं आहे कलेक्ट केलेलं आहे स्टोअर केलेलं आहे मला फक्त त्यातले 2च सॅम्पलचं चेक करायचं आहे अनालिसिस. So I can select only these 2 samples for the NMR analysis. So that's why this third one is very good and have good very advantageous method over the first and second. Okay, that's why it is called loop or cartridge storage mode. So these are the 3 modes of the operation. Now let's check the online flow mode. Okay. आता याच्यामध्ये तुम्हाला लक्षात ठेवायचं शब्दशः अर्थ आहे ऑनलाइन फ्लो मोड. सो व्हॉट हॅपन्स इन ऑनलाइन फ्लो मोड द आउटलेट ऑफ LC डिटेक्टर इज कनेक्टेड डायरेक्टली टू द NMR प्रोब. जसं आपण बघितलं तर दिस इज द आउटलेट वी कॅन से दॅट the sample comes after the LC detector so it becomes outlet and it directly connects to the NMR side. Okay. So this is the first point, directly connected to the NMR probe and while the compound peaks are eluting. जसं बाहेर येत असेल ते डायरेक्टली जाईल आणि त्यांचा स्पेक्ट्रा रेकॉर्ड होईल म्हणजे ते सॅम्पल अनालाइज होईल बाय द NMR. The chromatography system is used to separate and move the compound through the NMR probe of the detector. सिंपल सांगितलेलं आहे जसं आपलं सेपरेशन झालं की ते सॅम्पल पास होईल आणि त्याचं अनालिसिस होईल. So continuous flow is the easiest step. आता जसं तुम्ही डायग्राम मध्ये बघितलं so we can say that it is simple process. Okay, since it doesn't involve any different kinds of process. So we can say that's why it is simple and doesn't involve any synchronization between the separation and the detection system. बरोबर. LC आणि NMR मध्ये दुसरं कुठलंही ऑपरेशन करायचं नाही म्हणजे आपल्याला काही चेंजेस करायचे नाही आलं सॅम्पल बी पुढे पाठवायचं आहे. दॅट्स वाय दिस टेक्निक or one flow mode is the simple one and thereby maintain a good separation results. आणि याच्यातून आपल्याला एक फायदा होतो त्याच्यापासून आपल्याला गुड सेपरेशन रिझोल्युशन मिळू शकतं. बट ड्रॉबॅक आहे जसं एखाद्या सिस्टम चांगलं असेल तर त्याच्यासोबत काही ना काही ड्रॉबॅक्स येत असतात. So this online flow mode has some drawbacks. What is that? The first one is that it has oversensitivity due to the fact that the eluted peaks get a short duration of exposure time in the detection cell. That is the NMR flow cell. म्हणजे दिस इज द कंटिन्युअस फ्लो. आपल्याला सॅम्पल थांबवता येत नाही जसं सॅम्पल आला की पास होणार. त्यामुळे NMR मध्ये काय होतं NMR मध्ये आलं म्हणजे त्या सॅम्पल होल्डर मध्ये आलं की ते पास होतच राहणार पुढे ते सॅम्पल तिथं पण थांबणार नाही बरोबर कारण इट इज अ कंटिन्युअस फ्लो मोड. सो दॅट्स वाय ड्युरेशन ऑफ एक्सपोजर NMR मध्ये जे आपल्याला एक्सपोजरचा टाइम मिळतो तो खूप कमी मिळतो. दॅट्स वाय इट लुजेस इट्स सेन्सिटिव्हिटी. बरोबर, त्यामुळे त्याचं सेन्सिटिव्हिटी थोडीशी कमी होते. Additionally, the chemical shift of a sample as well as the solvent depends on the solvent property. So this is second drawbacks. Okay, chemical shift तुम्हाला सर्वांना माहिती आहे. What is meant by chemical shift? Okay, and this chemical shift and solvent chemical shift is depend on the solvent property which may cause shifting of the position in the NMR phase. हे सॉल्व्हंट आणि सॅम्पल जर तुम्ही थोडंसं ओव्हरलॅप झाल्यामुळे केमिकल शिफ्ट मध्ये चेंज होऊ शकतो. सो दिस इज द सेकंड ड्रॉबॅक्स. ओके, नाउ नेक्स्ट वन इज द स्टॉप फ्लो मोड. बरोबर, आता स्टॉप फ्लो मोड मध्ये आपल्याला माहिती आहे की आपण सॅम्पल थोडं स्टॉप करू शकतो, थांबवू शकतो. म्हणजे आपल्याला जे सॅम्पल पाहिजे तिथं आपण थांबवू शकतो. सो वी कॅन से दॅट इन दिस मोड और स्टॉप फ्लो मोड the NMR probe, म्हणजे जे NMR instrument आहे, is directly connected to the outlet of the LC detector at the interface. So there will be no direct connection. Okay. Second, it has better sensitivity as compared to the online flow mode with better signal to noise ratio. बरोबर आहे. आता हे सिग्नल टू नॉइज रेशो तुम्हाला काय सांगतो. So you can see that this stop flow mode operation has better sensitivity as compared to the online flow mode with better signal to noise ratio. Okay, here I have one picture. Okay, just a minute. Okay, so this is the image. You can see that there are two spectra obtained for the same compound just by using different modes of operation. Okay, एक सॅम्पल आहे त्याचा आपण NMR स्पेक्ट्रा केलेला आहे पण वेगवेगळ्या मेथडनं. पहिलं आहे स्टॉप फ्लो मोड आणि बी आहे ऑन फ्लो मोड. So you can clearly see the separation as well as the resolution. Okay, and you can see that the intensity of the peaks. जर तुम्ही खालच्या डायग्राम मध्ये बघितलं, खालच्या स्पेक्ट्रा मध्ये बघितलं तर तुमचं रिझोल्युशन चांगलं नाहीये. बरोबर आहे, आणि इंटेन्सिटी पण तुम्हाला एवढी क्लिअर दिसत नाहीये. सो यू कॅनॉट मेक एनी डिफरन्स बिटवीन दिस पीक अँड अदर पीक्स. ओके, देर आर व्हेरी नॉईज. हे जर बघितलं तुम्ही नॉईज भरपूर आहे. बरोबर आहे, स्मॉल पीक. हे असं जे स्मॉल पीक असेल तर आपण त्याला नॉईज म्हणतो. And this is happens in the on flow mode. But in stop flow mode, you can see that this noise is very less. Noise कमी, एकदम खूप कमी आहे. बरोबर, आणि peak intensity, peak height, you can see that it is very high intensity. Also, its height is very large, and you can see that there is a clear separation. जर तुम्ही इथं बघितलं ह्या तीन पीक मध्ये आणि ह्याच्यामध्ये बघितलं separation एवढं व्यवस्थित क्लिअर दिसत नाही. पण here you can see that separation is good. So you can measure its delta value or chemical shift easily. So this is the advantage of stop flow mode over the on flow mode. So it has better sensitivity. आता आपण जसं बघितलं as compared to the on flow mode. It also permits the detection of only selected peaks of our interest with the help of walls found in the interface. बरोबर आहे. आपल्याला समजा तीन सॅम्पल आहे, एका मिक्सर मध्ये तीन कंपाऊंड आहे आणि पहिला कंपाऊंड येणार, दुसरा कंपाऊंड येणार, तिसरा कंपाऊंड येणार, वन बाय वन. पण मला पहिल्या कंपाऊंडचं अनालिसिस करायचं नाही. बरोबर, सो आय कॅन थ्रो दिस सॅम्पल ॲज अ वेस्ट. पहिलं सॅम्पल मी काय करू शकतो, बाहेर टाकून देऊ शकतो थ्रू द वॉल. जो आपला 3-वे वॉल असतो त्याच्यातून मी तो सॅम्पल बाहेर टाकू शकतो. म्हणजे मला ज्या सॅम्पलचं अनालिसिस करायचं आहे त्या सॅम्पलचं अनालिसिस मी करू शकतो. 5 पैकी मला एकच करायचं आहे किंवा 5 सॅम्पलचं मला अनालिसिस करायचं आहे ते करू शकतो मी बाय युजिंग स्टॉप फ्लो मोड. ओके, सो आफ्टर द इल्युटेड पीक्स detected by the LC detector and reached in the NMR detection cell, the chromatographic working condition should be stopped until the NMR signals are acquired. So this is the important point. आता हे मशीन कसं काम करते किंवा हा मोड ऑफ ऑपरेशन कसं काम करतं ते सांगितलेलं आहे. तुम्ही एलसी मध्ये HPLC मध्ये सॅम्पल इंजेक्ट केलं, समजा तुम्ही जे मिक्सचर इंजेक्ट केलंय त्याच्यामध्ये 4 कंपाऊंड आहे, 4 डिफरंट कंपाऊंड आहे. बरोबर, आता ज्यावेळेस तुम्हाला HPLC मध्ये दिसते पहिलं सॅम्पलचा पीक आलेला आहे म्हणजे पहिला सॅम्पल पूर्णपणे कॉलम मधनं पास झालेला आहे आणि तो बाहेर पडणार आहे एलसी मधनं, बरोबर आहे. तो एलसी मधनं बाहेर पडला म्हणजे एलसी मधनं आउटलेट झाला की तो एनएमआर मध्ये जाणार आहे, बरोबर. मग ज्यावेळेस तो एलसी मधनं बाहेर पडेल त्यावेळेस तिथं आपल्याला एलसी म्हणजे एचपीएलसी आहे ते मशीन आपल्याला थोडे वेळ बंद करायचं आहे. बंद करायचं म्हणजे काय करायचंय, जो आपण पंप वापरतो तो पंप आपल्याला स्विच ऑफ करायचा आहे. याच्यामुळे काय होईल की जे पुढं सेपरेशन होणार आहे सेकंड थर्ड कंपाऊंडचं ते काय होईल तिथंच थांबेल जाग्यावर. पुढचं कंपाऊंड बाहेर येणार नाही सेकंड, फक्त पहिलाच कंपाऊंड काय होईल बाहेर येऊन एनएमआर मध्ये जाईल, बरोबर. मग ज्यावेळेस पहिल्या कंपाऊंडचं टोटल एनएमआर अनालिसिस होईल त्यावेळेस तुम्हाला परत पंप चालू करायचा आहे. ओके, so after analysis of the first sample by NMR, then you have to start the pump again. Okay, so what will happen when you start the pump again? So second sample will start to come out. Okay, दुसरं sample बाहेर यायला लागेल. So when it comes out and enters into the NMR, then you have to stop the pump again. तर तुम्हाला पंप बंद करायचा आहे. जर पंप बंद नाही केला तर काय होईल, तिसरं पण सॅम्पल बाहेर येईल. So it will create some problem. So this is the small disadvantage of this method. So means you have to stop the pump and then restart the pump. This is the process you have to do in this stop flow mode method. Okay, got it? समजलं सर्वांना हे?
सर.
Okay.
Yes, sir.
ओके, ह्या स्टॉप फ्लो मध्ये म्हणजे थोडंसं मॉडिफिकेशन आहे. ठीक आहे, प्रोसेस दोघांचे प्रिन्सिपल सेमच आहे, थोडंसं मॉडिफिकेशन आहे आणि त्या मॉडिफिकेशन आपण म्हणतो टाइम स्लाइस मोड, बरोबर आहे. तो व्हॉट इज मीन बाय टाइम स्लाइस मोड, लेट्स चेक आउट. So the time slice mode is modified extension of the stop flow mode where the flow is stopped at a regular and programmed intervals. आपण त्याला सेटिंग करू शकतो. आता आपल्याला जे नवीन इन्स्ट्रुमेंट येतात त्याचं आपण कॉम्प्युटरच्या सहाय्याने सेटिंग करू शकतो. म्हणजे ज्या पॉईंटला थांबायचं आहे त्या पॉईंटला आपण थांबू शकतो आणि परत चालू करू शकतो. ओके, द मेजर ॲडव्हान्टेज ऑफ टाइम स्लाइस मोड इज दॅट इट कॅन बी यूज when the separation is poor. For example, in identifying two analytes having close retention time. बरोबर आहे. याच्या सहाय्याने आपण ज्या सॅम्पलचं सेपरेशन पुअर आहे त्यासाठी आपण हे वापरू शकतो. म्हणजे काय, समजा एका मिक्सरमध्ये 3 सॅम्पल आहे आणि त्याच्यातलं फर्स्ट अँड सेकंड सॅम्पलचं सेपरेशन होतच नाही एलसीनं लवकर, किंवा त्यांच्यामधलं सेपरेशनचं रिटेन्शन टाइम खूप कमी आहे, त्यावेळेस आपण हे वापरू शकतो, बरोबर आहे. सो दॅट्स वाय इट इज कॉल्ड टाइम स्लाइस. तुम्ही स्लाइस करू शकता. स्लाइस म्हणजे काय, जसं स्लाइसला आपण मराठीत काय म्हणतो, व्हॉट इज मीन बाय स्लाइस इन मराठी, माहित आहे का नाही?
Sir, piece.
हा,
Small piece.
आवाज येत नाही तुमचा.
Sir, small piece.
स्मॉल पीस. ओके, हा, स्मॉल पीस असेल म्हणजे आपण ज्या ठिकाणी आपल्याला कट करायचं आहे त्या ठिकाणी आपण सॅम्पल कट करू शकतो. म्हणजे तुम्हाला समजा एक पहिला मध्ये पहिला पीक येतोय 3 मिनिटांनी, दुसरा पीक येते 3 मिनिटांनी आणि 10 सेकंद. ओके, म्हणजे ह्यांच्या दोघांमध्ये फक्त 10 सेकंदचाच फरक आहे. जर स्टॉप फ्लो मोडमध्ये केलं तर थोडंसं आपल्याला अवघड जातंय. पण माझ्याकडे जर सिस्टीम अशी असेल ज्याच्यामध्ये मी प्रोग्राम करू शकतो किंवा मला ज्या ठिकाणी थांबायचं आहे त्या ठिकाणी जर मला ॲडजस्टमेंट करता आली तर इट विल बी बेटर. सो आय कॅन गिव्ह और आय कॅन अरेंज अ प्रोग्राम इन सच वे दॅट दिस मशीन विल स्टॉप आफ्टर 3 मिनिट 5 सेकंद. म्हणजे 3 मिनिटं 5 सेकंदानंतर ती सॅम्पल तिथंच किंवा मशीन थांबेल, बरोबर. त्यामुळे फक्त पहिलं सॅम्पल बाहेर पडेल, दुसरं सॅम्पल तिथंच राहील. दॅट्स वाय इट इज कॉल्ड टाइम स्लाइस मोड. दोघांचं वर्किंग सेम आहे, फक्त ऑपरेशन थोडंसं डिफरंट आहे. So generally, the major disadvantage of stop flow mode may be it is dependent for the separation resolve greater than 2 minute retention time. म्हणजे जर 2 पीक मधलं रिटेन्शन टाइम म्हणजे 2 पीक मधला फरक जर 2 मिनिटापेक्षा जास्त असेल तरच तुम्ही स्टॉप फ्लो वापरू शकता. पण जर 2 पीक 2 मिनिटाच्या कमी अंतराने येत असेल म्हणजे जसं मी तुम्हाला सांगितलं, एक पीक 3 मिनिटांनी आणि दुसरा पीक 3 मिनिटं 10 सेकंदांनी येत असेल तर तुम्ही स्टॉप फ्लो मेथड वापरू शकत नाही. Then you have to go for the time slice. Okay, so this is the disadvantage of the stop flow. Now next, which is very important and good as compared to the previous two, it is called loop or cartridge storage mode. ठीक आहे, मी परत एकदा इमेज कडे जातो. Okay, here. So here you can see that there is an interface. This interface is called the loop or cartridge storage. Okay, so loop means there are a lot of loops where you can store the sample. बरोबर आहे. म्हणजे तुम्हाला ज्या सॅम्पल इथनं पास झालं, डिटेक्टर मधनं बाहेर पडलं की तुम्हाला फक्त सॅम्पल कलेक्ट करायचे, वेगवेगळे सॅम्पल. जसा पीक आला सॅम्पल कलेक्ट केला, दुसरा पीक आला तो सॅम्पल दुसऱ्या लूप मध्ये कलेक्ट केला, तिसरा सॅम्पल आला तिसऱ्या लूप मध्ये तुम्ही कलेक्ट केला. सो यू कलेक्ट ऑल दिस सॅम्पल्स इन अ डिफरंट लूप. बरोबर आहे. आपल्याकडे 5 लूप असतील, 5 कंपाऊंड असतील तर आपल्याला 5 लूप वापरावे लागतील. बरोबर. आता ज्या वेळेस हे सॅम्पल होईल, बाहेर पडतील, तुम्ही स्टोअर कराल, फक्त तुम्हाला ज्या सॅम्पलचं पाहिजे त्या सॅम्पलचं तुम्ही अनालिसिस करू शकता. बरोबर. सो दिस इज द ॲडव्हान्टेज ऑफ दिस लूप स्टोरेज मोड. Okay, let's check out. In this type of mode, the outlet of the LC detector must be connected directly to the sample storage loop. Okay, so this acts as an interface between the LC and NMR. Okay, that is the loop storage or cartridge. This cartridge is called as the solid phase extraction. Okay, this solid phase extraction काय आहे ते तुम्हाला पुढच्या पॉइंट मध्ये सांगणार आहे. So either you can use loop storage or cartridge. Cartridge means solid phase extraction. It is called the SPE in capitals. Okay. An LC detector is employed to monitor eluted peaks from the column in parallel. याच्या आपण LC detector आपण मॉनिटर करू शकतो, कुठला पीक यायला लागलाय, कुठला पीक अजून आला नाही. So we can check out. Then the detected peak is directed and collected in either the sample loops or SPE. जर तुम्हाला वाटलं तर सॅम्पल्स यायला लागले, म्हणजे पीक यायला लागला, याचा अर्थ काय की सॅम्पल्स यायला लागलेला आहे. सो दॅट सॅम्पल यू कॅन कलेक्ट इन टू द सॅम्पल लूप्स ऑर SPE विथ द हेल्प ऑफ chromatographic working conditions. Okay, so when the separation is completed, the LC pump again can be used to push the pre-collected peaks into the NMR flow cell by using a valve. आता काय समजा आपल्या एका मिक्सर मध्ये 4 कंपाऊंड आहे, 4ही कंपाऊंड तुम्ही सेपरेट केले आणि 4ही कंपाऊंड तुम्ही कलेक्ट केले. बरोबर. म्हणजे आता एसपीएलसीचं काम संपलेलं आहे. तिथं आपल्याला काय करायचं, फक्त पंप वापरायचा त्या ठिकाणी. कशासाठी पंप वापरायचा आहे, ते सॅम्पल फक्त थोडं एनएमआर मध्ये पुश करण्यासाठी. सो यू हॅव टू टेक दॅट सॅम्पल इन टू द एनएमआर पार्ट. फक्त एनएमआर सॅम्पल पास करण्यासाठी आपण पंप वापरू शकतो. ठीक आहे. सो loop storage gives better peak resolution as compared to the direct stop flow mode. याच्या सहाय्याने आपल्याला एक चांगला फायदा होतो की तुम्हाला रिझोल्युशन चांगलं भेटतं. ओके. आणि ह्याचा नेक्स्ट ॲडव्हान्टेज काय ते या पॉइंट मध्ये सांगितलेलं आहे. Even though the loop storage mode avoids the consumption of expensive deteriorated solvent throughout the experiment, there might be sample decomposition. So this is a small disadvantage of this system or mode of operation. ह्याच्यामध्ये तुम्हाला ॲडव्हान्टेज काय आहे की जो आपण एनएमआर मध्ये सॉल्व्हंट वापरतो, डिटोरेटेड सॉल्व्हंट, फॉर एक्झाम्पल DTO और CDCl3, त्याला तुमचं अमाऊंट खूप कमी लागते हे सॅम्पल्स. पण त्याचा एक छोटासा ड्रॉबॅक काय, ह्याच्यामध्ये सॅम्पलचं डिकम्पोजिशन होण्याचा चान्स जास्त आहे. ओके. सो दिस इज द ओनली डिसएडवांटेज अंडर दिस मोड ऑफ ऑपरेशन्स. ओके. सो it requires additional special pumping equipment to elute samples from the temporary storage. म्हणजे जसं मी तुम्हाला सांगितलं, एकदा स्टोअर मध्ये सॅम्पल केलं की तुम्हाला ते पंपच्या साह्यानं एनएमआर मध्ये पास करायचं आहे. सो दिस इज द ॲडिशनल रिक्वायरमेंट फॉर द लूप स्टोरेज मोड. ओके. आता हे जर तुम्ही रिझोल्युशन बघू शकता, जर तुम्ही सेम सॅम्पल केलं 2 वेगळ्या पद्धतीनं, ओके, तर तुम्हाला लक्षात येईल की सॅम्पलचं सेपरेशन रिझोल्युशन कुठलं चांगलं आहे. ओके. पहिलं आहे ए मध्ये डायरेक्ट stop flow mode. Okay, so this is the NMR signals after using direct stop flow mode. आणि सेकंड आहे लूप स्टोरेज ऑफ लूप ट्रान्सफर प्रोसिजर. याच्यामध्ये तुम्ही बघू शकता पीक्स आहेत. So these are the two compounds in the given mixture. Also there is a loop storage म्हणजे दोन सेपरेट कंपाऊंड आहेत. आता तुम्ही फक्त याच्यातलं कुठला पोर्शन सिलेक्ट करायचा ते तुम्ही ठरवू शकता. म्हणजे तुम्ही सॅम्पल जेव्हा स्टोअर करतात त्यावेळेस तुम्ही काय करू शकता, ज्यावेळेस सॅम्पल बाहेर यायला लागलं की एवढाच पोर्शन तुम्ही काय करू शकता, कलेक्ट करू शकता. हा पोर्शन तुम्ही निग्लेक्ट करू शकता, बरोबर. कारण याच्यामध्ये थोडंसं कंटॅमिनेशन व्हायचे चान्सेस जास्त असते. म्हणजे ज्यावेळेस हा सॅम्पल बाहेर येत असेल ह्या वेळेस त्यावेळेस याच्यासोबत दुसरं कंपाऊंडचं पण कंपाऊंड येऊ शकतो. सो यू कॅन सिलेक्ट ओनली रिक्वायर्ड पोर्शन इन द स्टोरेज लॅम्प. दॅट्स वाय इट्स सेन्सिटिव्हिटी गेट बेटर. त्याच्यामुळे तुम्हाला सेन्सिटिव्हिटी जास्त मिळते. कारण आपल्याला जे पाहिजे तेच आपण कलेक्ट करणार आहे. बाकीचं तुम्हाला वाटलं त्याच्यामध्ये थोडं मिक्सचर असेल, कंटॅमिनेशन असेल, सो यू कॅन अवॉइड दॅट सॅम्पल. And that's why you can see that there is a clear separation of the two signals in the NMR. बरोबर. तुम्ही इथे बघू शकता याच्यामध्ये तर तुम्हाला कंबाईन झालेलं दिसेल, पण NMR इथं लूप मध्ये तुम्हाला सेपरेट झालेलं दिसू शकतं. ओके, सो among three the storage loop is the better one as compared to the direct or stop. Okay, so here is another example which explain about these three mode of operations. Okay, just we will see this slide. So here this is the sample. या sample मध्ये तीन कंपाऊंड आहे, एक रेड, एक ग्रीन आणि एक ब्लू. म्हणजे एका मिक्सर मध्ये तीन कंपाऊंड वेगवेगळे आहेत. HPLC काय करेल ते त्यांना सेपरेट करेल. So here you can see that HPLC detector detects all these samples and it will separate all these samples. Now either we can go by on flow, stop flow or transfer. हे दोघं जे आहेत ते सेम आहे, स्टोरेज लूपचे आहेत. ओके, पण जे इन्स्ट्रुमेंट कंपनी आहे ब्रोकर त्यांना ह्याला थोडंसं मॉडिफिकेशन केलेलं आहे आणि त्यांचं इन्स्ट्रुमेंट कसं चांगलं आहे ते एवढं सांगितलेलं आहे याच्यामध्ये. ते आपल्याला काही घेणं देणं नाहीये. आपल्या तीनच मोड आहेत, ऑन फ्लो, स्टॉप फ्लो अँड स्टोरेज लो. आता हे तिन्ही सॅम्पल येणार स्टॉप फ्लो मध्ये. ठीक आहे, स्टॉप फ्लो मध्ये काहीच हे नाही आहे, सॉरी चार हे आहेत मिक्सर, एक सॉल्व्हंटचा असतो. ओके, सॅम्पल आणणार, ह्याला काही स्टॉप नाही, डायरेक्ट सातारावरून निघालाही कोल्हापूर, कोल्हापूरहून निघालाही सातारा, कुठं स्टॉप नाही. सो यू कॅन सी दॅट ऑल द पिक्स आर इन द NMR विदाउट एनी रिझोल्युशन और सेपरेशन. ते थोडं पीक आपल्याला एवढं व्यवस्थित क्लिअर मिळत नाही. तर दिस इज द ऑन फ्लो. आता स्टॉप फ्लो मध्ये काय होतं, सो यू कॅन टेक स्टॉप ॲट द कराट और समवेअर बिटवीन फॉर द स्नॅक्स. आणि आपल्याला जिथं पाहिजे सॅम्पल ते आपण सॅम्पल पास करू शकतो. म्हणजे काय होईल, LC मधनं 4 सॅम्पल्स बाहेर आले, बरोबर आहे. हा पहिला आहे, दुसरा आहे, तिसरा आहे. मला समजा हा पहिला सॅम्पल नको आहे, तर मी काय करू शकतो, त्याला आउटलेट मधनं बाहेर काढू शकतो. NMR मध्ये पास करायचंच नाही त्याला, बरोबर आहे. आपल्याकडे 3 वे ऑल आहे. 3 वे ऑल मधनं आपण काय करू शकतो, त्याला बाहेर काढू शकतो, बरोबर. आणि पुढचा सॅम्पल आपण पास करू शकतो. ठीक आहे. सो द सॅम्पल विच इज रिक्वायर्ड फॉर अनालिसिस यू कॅन सिलेक्ट, ठीक आहे, बाय युजिंग द स्टॉप फ्लो मोड. आणि इथे तुम्हाला सेपरेशन दिसू शकतो. जर तुम्ही फक्त रेड घ्यायचं आणि हे ग्रीन आणि ब्ल्यू घ्यायचं नसेल, यू कॅन डू इट and you will get the only signal for the red sample. तसं तुम्ही ग्रीनचं पण करू शकता. Now third method is the storage lamp. Okay, storage loop. आता याच्यामध्ये तुम्ही काय केलेलं आहे, सॅम्पल स्टोअर केलेलं आहे वेगवेगळ्या कंपाऊंड मध्ये, बरोबर. आता ग्रीन पहिल्यांदा येतंय, रेड नंतर आहे, देन ब्ल्यू. तुम्हाला ज्या सॅम्पलचं पाहिजे त्या सॅम्पलचं तुम्ही अनालिसिस करू शकता. जस्ट यू हॅव टू टर्न द ऑल. कुठल्या सॅम्पल पाहिजे त्याचा ऑल तुम्हाला ऑन करायचा, ते सॅम्पल NMR मध्ये सबमिट होईल. आणि ह्या स्टोरेज लूपचा एक फायदा काय आहे की ह्या सॅम्पलचं तुम्ही कॉन्सन्ट्रेशन करू शकता. म्हणजे हे जे सॉल्व्हंट आहे आता ह्याच्यामध्ये बघितलं असेल आपण, हा एक सॉल्व्हंटचा पीक आहे, हा सॉल्व्हंटचा पीक आहे. याच्यामध्ये पण असणार आहे, पण तो सॉल्व्हंटचा पीक आपण कमी करू शकतो. आणि इट इज कॉल्ड सॉल्व्हंट सेपरेशन प्रोसिजर. ठीक आहे. सॉल्व्हंट सेपरेशन काय होतं की पीकची सेन्सिटिव्हिटी काय आहे ते जास्त होते. बरोबर आहे. आता सॅम्पल आपण सॉल्व्हंट नेहमी आपण जास्त प्रमाणात घेतो ॲज कम्पेअर टू द सॅम्पल. सो once you do the solvent separation, you get the better sensitivity, a better selectivity. ठीक आहे. जर तुम्ही याच्यामध्ये बघितलं ग्रीनचं आणि ह्याच्यामध्ये, तर ग्रीनचे पीक्स तुम्हाला चांगले दिसतात ॲज कम्पेअर टू द अप्पर वन. ठीक आहे. आणि हे तिसरं आहे तेच SPE. बरोबर आहे. सॉल्व्हंट फेज एक्स्ट्रॅक्शन म्हणजे काय, याच्यामध्ये तुम्ही सॉल्व्हंट कमी करू शकत नाही, पण जर थोडंसं मॉडिफाय केलं आणि त्याच्यातलं सॉल्व्हंट कमी केलं, जसं या इन्स्ट्रुमेंटमध्ये आहे, त्या इन्स्ट्रुमेंटचं नाव आहे ब्रुकर. याच्यामध्ये काय करू शकता, जे सॉल्व्हंट आहे त्याचं कॉन्सन्ट्रेशन कमी केलं की ऑब्विसली काय होईल, सॅम्पलचं कॉन्सन्ट्रेशन वाढेल. बरोबर. अँड यू विल गेट द हाय रिझोल्युशन आणि हाय इंटेन्सिटी ऑफ द सॅम्पल. ठीक आहे. दॅट्स वाय द स्टोरेज, both are the storage, but there is a slight difference. That's why this storage loop or SPG method is very good as compared to the stop flow and on flow. हे तुम्हाला लक्षात ठेवावं लागेल. सो याच्यात प्रश्न येऊ शकतोय, पूर्ण ह्याच्यावर आला तर 10 मार्काला येईल. जर याच्यातलं एकच विचारलं तर 5 मार्काला प्रश्न येऊ शकेल. बरोबर. कुठं विचारतात ते डिपेंड्स आहे. 10 मार्क विचारला तर यू हॅव टू एक्सप्लेन फ्रॉम दिस स्लाइड what is meant by mode of operation. So mode of operation is nothing but the passing the sample outlet from the LC to the NMR. ठीक आहे. त्याच्यात किती प्रकार आहे ते सांगायचं आणि नंतर प्रत्येक थोडं थोडं एक्सप्रेशन लिहायचं. ओके. आणि त्यांचे ॲडव्हान्टेज डिसॲडव्हान्टेज यू हॅव टू टेल. ठीक आहे. हे डायग्राम पण काढू शकतात, सिम्पल आहे. सो इट विल बी इफेक्टिव्ह. ठीक आहे. तर आपण या ठिकाणी थांबूया. सिन्स वी हॅव सम वर्कशॉप. Okay. So far is there any doubt? याच्यामध्ये काय डाउट्स आहेत का? ऑन फ्लो, स्टॉप फ्लो अँड स्टोरेज लो.
सर पण हे इन्स्ट्रुमेंट्स आम्हाला भेटतील का? आपल्या कॉलेजमध्ये काही नाही आहे ना, तर ह्याचं प्रॅक्टिकल वर्क नाही होणार ना काय?
ह्याचं प्रॅक्टिकल इन्स्ट्रुमेंट खूप महाग आहे. तर तुम्ही डिसएडव्हान्टेज बघितलं तर लक्षात येईल याची कॉस्ट इन करोड्स. बरोबर आहे. आपल्या इथं नाही आहे. जिथं नॅशनल इन्स्टिट्यूट आहे त्या ठिकाणी हे असतात. त्यामुळे बघायचं म्हटलं तर आपल्याला तिथं जावं लागेल. आपल्या इथं फक्त आता नवीन SCM आलेलं आहे, सेम टेक्निक आलेलं आहे, UV आहे, IR आहे, HPLC तुम्ही बघू शकता. जर समजा तुम्हाला सेकंड टर्म मध्ये किंवा आफ्टर नोव्हेंबर you can, if you come in college, you can see the HPLC.
ओके.
हा पॉईंट महत्वाचा लक्षात असू द्या परीक्षेच्या दृष्टीने, कारण LCNM मध्ये महत्वाचंच आहे की कशा तुमचे पीक इंटेन्सिटी आणि सिग्नल कशावर डिपेंड आहे, त्याच्या प्रोसेसवर डिपेंड आहे. जर चांगलं रिझोल्युशन, चांगली क्लिअरिटी पाहिजे असेल तर यू हॅव टू गो फॉर द स्टोरेज ग्रुप. ठीक आहे. तर याच्यानंतर पुढचा एक पॉईंट आहे की सेन्सिटिव्हिटी कसं वाढवायची सॅम्पलची. ठीक आहे. ते आपण पुढे बघणार आहे. आणि देन इट्स ॲडव्हान्टेजेस, डिसॲडव्हान्टेजेस अँड इट्स ॲप्लिकेशन, हे 2 पॉईंट राहिलेले आता LCNM मध्ये. ठीक आहे. In next lecture, we will cover that these 2 points, and then we'll go for the last technique. Okay. So, काही doubt असतील तर विचारू शकता. Otherwise, we will stop here. Okay. Shall we stop?
Yes, sir.
येस सर.
Okay. But remember, at 11 o'clock, you have a COC exam. आणि प्रत्येकाने द्या. तुमच्या मित्रांना पण सांगा. ठीक आहे.
हो सर.
तुमची एक्झाम आहे सर्वांना सांगा. ओके. गुड. अँड बेस्ट लक.
थँक्यू सर.
Thank you, sir.
Calcium